Okay, so here's the first shape I made, and you can see actually it is sort of made out of line segments. What is this shape?
It's two tetrahedrons.
This is two tetrahedrons. And I cheated a little bit. And did something just slightly different than what I told you in the first part of the project. What I did was I made, using our F3 program, I just made the tetrahedron. And then I added a tetrahedron where I replaced the x and y coordinates, actually and the z coordinates since this is in 3 dimensions, with all their absolute values.
Okay. So there could be two possibilities for a number.
Yeah.
Actually more if you're using 3 coordinates.
Yeah, actually interesting. So how many possibilities are there?
So I think there's six possibilities that would all go to the same x, y, z.
Why do you think that?
Because you can have, or no, there'd be actually 8 possibilities because each of your x, y, and z could either be positive or negative.
Right. So what made you think that was 6?
I don't know.
Okay. Well, so each one can be positive or negative. So you multiply 2 times 2 times 2 and you get 8. So we have each point actually goes to 8 points. Or, sorry, each point actually comes from 8 points. And you get an interesting shape that turns out to be 2 tetrahedrons.
Cool.
But now I'm going to take this shape and replace x, y, and z by x squared, y squared, and z squared. What do you think is going to happen to the shape?
Well, maybe you'll get some new points, and maybe some old points may not fit our equation anymore.
Alright, what do you think?
Well, so if we thought it was a straight line, if we thought when we changed it in 2 dimensions it would be a straight line, then this would be maybe a straight line if it would just be like maybe bigger, but
Okay. Well, here's what happens.
so
I get this shape.
Well, it looks
there.
might be a little bigger actually.
Oh, yeah. So I wasn't careful this time about the scaling. Actually, it was one thing I wish I would have been more careful about. So
they're supposed to be the same size?
Well, had I done it the way I would like to have done it, the corners would all be at the same points. And the shape would be growing a little bit.
But like not a lot.
But you can see that, I probably can't see it on camera, but you can see the corners don't line up properly. So I should have made the corners 1 unit away from the origin so that when everything squares, they stay 1 away. But I actually forgot to do that.
Well, let's see.
So how would you describe this shape?
Well,
It doesn't look like there are only straight lines anymore.
Yeah, you have this.
You have a curve.
Curves.
All of these edges are straight lines.
All the edges are straight lines, but I do seem to have picked up some curves.
So you added some new areas, like in here, there's more points that you got in here now.
Okay, so cool. So how would you describe this shape?
Well, maybe you sort of like inflated the shape.
You take like some tin foil and wrap it around, and it gets more rounded.
It's more rounded.
For the corners.
And here's the shape that looks, here's what it looks like when I replace it with x, y, and z with x cubed, y cubed, and z cubed. Although, because I started out with absolute values in the first one, this is actually absolute value, x cubed, absolute value, y cubed, absolute value, z cubed.
And then here it looks like it's getting more these are sort of filling out more.
You still got like you can faintly see.
But don't cover it up with your hand. So put your hand down here.
You can still faintly see the edges, and they're still straight lines.
Okay.
And but this is actually getting. It's not as sharp. It's not as sharp as a curve.
Yeah, and so.
It's just getting more flat.
And here it is when I did x to the 4th, y to the 4th, z to the 4th.
It's kind of looking like a cube.
Yeah.
But like with these sort of pulled out edges and corners.
Yeah, so put your hand low. Yeah, there you go. And then and get it close to the snap cube. Pretty cool, huh?
Yeah.
All right, so now I got a challenge question for you.